Hello, welcome to the garage. Last time I left you, we were ordering some boards. So in the meantime, I've been playing with the Wi-Fi module, trying to program it to work with the Open Inverter board. So while I'm waiting for the GLC PCB boards to arrive, I've been programming this module and I couldn't just get it to work. So I had a really silly problem and I've been pulling my hair out, but I can't figure out what was wrong with it. Now I want to show you what was the problem and what did I do to resolve it. Let's have a look, see what happens. First, you have to download and install Arduino. You can search it on Google and find quite easily. In this case, I'm using the older IDE version 1.8.13 because I had troubles with running the latest one. So once you download it, Arduino, you just run an installer and install, just following a standard installation with it. As I already have it installed, I will not go through this in details. Step 2. Inside Arduino IDE, go to File, Preferences, and copy URL shown on the screen. This will add ESP8266 to the additional board manager. Go to Tools, Board, and select Board Manager. Type ESP8266 and the search will find appropriate support for this board. So select it and press Install. Board Manager will install the support files necessary for the ESP8266 board. Step 3. Add support for Python for Arduino ESP8266. I show the URL on the screen, so you can copy it and go to this website. Once you're on the website, download the zip file and extract it in the location of your choice. Once you've done that, go to the location where your Arduino is installed and copy the file ESP8266 jar into that location. So the path I will show on the screen as well. So it will be Documents, Arduino, Tools, ESP8266 and tool, and then you copy it into that location. If those folders are not present on your PC, you may have to create them. Step 4. Download Johannes Hubner web interface code. You can go to the URL shown in the description and on the screen. Once you've downloaded the web interface, store it in the folder of your choice and unzip all the files in the same folder. After this, you go to Documents and find the Arduino folder and create a new folder called FS Browser. Once FS Browser is created, you go into that folder and you need to copy all the files that you unzipped from the archive you downloaded, and you copy them into the FS Browser folder. Once you've done that, in FS Browser you can create a new folder called Data, and then you will need to copy all the files from FS Browser folder into the Data folder. As you see, I've done this, and I prefer to delete the fsbrowser.ini file. This is basically the Arduino file, to ensure that I don't run it from the data. So you need to ensure that you run fsbrowser.ini file from the FS Browser folder itself. And now once your Arduino up and running, at this stage we can plug in the Wi-Fi module. And in this case I'm using VMOS D1 Mini. As you can see, I'm checking the settings for the module, and we can start programming it. But this is where I actually had a problem. Every time I tried to program the code, it basically came up with an error and COM port 5 could not be opened. And it was very strange because basically I looked at the Arduino IDE and I found that the board was detected on COM 5. But when I actually went to select the port, I found that there was no tick box available for the port. And when I looked at the device manager, it also was not detected. I've reinstalled the driver for VMOS module and still was not able to see the module. And then I actually found the issue was with the cable. So I've replaced the cable, and after that the module was detected in device manager. Whenever I plug in, the device would appear in the device manager. There was a little issue that cost me a few hours and a little hair loss as well. So yeah, now you can see my attempt of programming which has failed. So now we can see the error message popping up. Now you can see a successful attempt in programming the Wi-Fi module. So this is a VMOS D1 Mini. So I've set up the memory, debug level, port, and check the board. And now we can start programming. port. Yeah, so I did verify the board was detected on COM6. So yeah, I've selected the COM6 and started compiling and programming the module. As you can see in a minute, so the programming was successful this time, and the last step I will need to do is to program spiffs. So yeah, that writing and verifying, and now tools, ESP sketch data upload. So this is programming spiffs, and it's 100%, and writing complete. Welcome back. Thanks for tuning in. Thanks for watching. Please give it a thumbs up and subscribe if you'd like to follow up with more videos from me on electric car conversion. So next video, I'm hoping I will get the boards from GLC PCB and will be continue on my work. In the meantime, I've programmed 2 boards. I've done VMOS D1 Mini, and I've done Olimex Wi-Fi board as well, and next step will be actually fitting the Open Inverter board into the Toyota Prius inverter, and start powering it up and programming the chips on the board. So thanks very much again, thanks for watching, and give it thumbs up and subscribe, and I will see you on the next video.